You know, if there's one thing I really enjoy about this hobby, it's getting the chance to play with a new system. A system that back in the day just totally passed me by. One that I have never played with before. Getting them now into the cave and getting a chance to tinker with it, see what it's all about. And one such system is this, the Sinclair ZX Spectrum. Believe it or not, this is the first Spectrum that I have ever held. And despite the fact that I live in the UK, and this was the definitive budget computer in the UK in the 80s, it has taken until 2022 for me to get my hands on one. And this may sound weird, but it's actually a bit bigger than I thought it would be. This rubber keyed wonder, that just feels terrible. How did anyone use these things? But this machine anyway, I bought it. Spurs of repairs, it doesn't work. So let's see if we can do something about that. And look, I don't mean to be overly harsh on this system. I know a lot of people have an awful lot of love for it. That keyboard though, I really would not have enjoyed typing in a basic program back in the 80s using this. I literally just tried to press a space bar. That doesn't exist. Space is over there. Yeah, it's certainly its own thing anyway, and obviously done for a reason, to keep the price of this little machine down. And I know it was thanks to its price point, that the Sinclair ZX Spectrum gave an awful lot of people their entry into the world of computers. This one though, as you can maybe tell, the front metal cover here, well, it has definitely seen better days. Bit of oxidization going on there. The paint is starting to bubble. So if we can get this machine working, I think we'll just have to replace that cover. I don't really see any means of rescuing it. The rest of the case though does seem to be in really good condition. It wobbles a bit, and that's because it's missing all 4 feet. But when I got this machine, it also came with a power supply. Genuine Sinclair power supply. Now when I got this, it didn't have a plug on the end of it. I've put that on. So has this maybe died? Could this be the reason that this machine itself doesn't work? Well, I say it doesn't work. I haven't tested it. But it was certainly listed as faulty. And there's also this funky looking device. Obviously plugs into the expansion slot on the back. Gives us a joystick port, which I assume is to the Atari standard. And there's also this 3-position switch on the back. I'll have to do a bit of homework and see what this thing is all about. The back of the machine, well, there's that expansion port I just mentioned. It's looking for a 9-volt DC input. So even if this is dead, presumably we can use the likes of a Mega Drive power brick to try and power this thing up. Or I suppose we can also use the bench power supply. Mic and ear inputs, presumably for connecting a tape deck. And this little machine only features an RF output. Now that in itself is going to be a bit of a problem, because I have nothing in here that is going to accept an RF input, well, other than the TV down the far end. But it is possible to do a really simple composite mod to this thing. And to be honest with you, despite the fact that this doesn't work, I think that is where we're going to start. Because we're going to need to get a video signal eventually. And just because this is so simple to do, let's get that done first. 5 screws to remove. Now I know we need to be really careful with the keyboard connectors because they are quite fragile. These ribbons just pull out. There's a problem. I don't think I have ever seen a capacitor explode like that. That has absolutely violated itself. That is unbelievable. So, dare I say, is this the cause of our faulty spectrum? Looks like I'll need to order a cap kit. And while we're waiting for new capacitors to arrive, let's quickly do this modification here. And that'll just let us get a video signal out of the Wii computer into my capture card. It is really straightforward though. One of these two is composite coming into the RF modulator. So all we're going to do is basically bypass this modulator, take that composite signal and connect it straight up to that jack. One more screw to remove in the middle here. That is just holding the board down. Our Sinclair ZX Spectrum 1983. This board is an issue 3B. Any signs of reworking in the past? And no, not really. Someone's had a go here though. Just here, one of these components has been replaced. Looks like that component there. And that is a ceramic capacitor. But for now, what we're interested in is this RF modulator. Now, as I said, one of these two is composite, the other is 5 volt. So let's see. Presumably that one is the 5 volt input. That one is the composite signal. And this mod really is as simple as disconnecting that wire, disconnecting that resistor from the jack, and running a new wire from the jack to that point. Basically just bypassing all of the RF modulator. So let's just pull that through. And I think equally we will disconnect it from the voltage rail as well. I need to disconnect that resistor. Just like that. In fact, let me try and tidy that up a bit. That's better. I have a little bit of wire here, and there's another spur hole that is not used, so we can thread that through there. And it just lines up beautifully with a hole that is on that jack. You'd almost think somebody thought about this. So I can solder the wire off there and then bend this down and through that hole. And that will be our composite mod complete. Now, I'm sure there are better ways to do this. In fact, I have seen little boards available that completely replace this RF modulator, and presumably they will give you a cleaner output. But for now, for me, this is going to be enough just so we can get a video signal and see if there's any life coming out of our spectrum. So what do you think would have caused this capacitor to go bang? Well, that is cap C50. And if we take a look on the schematic, and C50 is sitting between the positive and negative input from our power supply. Now the spectrum uses a center negative supply. So if someone were to fit a center positive supply in here, you'd be reversing the polarity across that capacitor, and that could very well cause it to explode. I suppose the other problem could be something drastically wrong with our power brick here. So let's just test this, and it is putting out 11.96 volts. Now that does seem quite high, doesn't it? Considering that our little spectrum is just looking for +9. But do bear in mind that there's no load under this thing at the minute, and hopefully when we do connect it up to the spectrum, that 11.9 would drop away down closer to the 9 volts that this machine is expecting. But I do think the cause of this explosion is somebody just using a non-compatible power supply, and hopefully this capacitor went before any damage was caused to anything else. The new capacitors have arrived. I got them from this place, Retro Revival Shop, for the ZX Spectrum. They seem to carry a decent selection of bits and pieces for this old machine, so worth checking them out if you're looking for anything. I'll stick a link in the video's description. It's not sponsored or anything. I just thought it looked like a useful website. I have plenty of stuff listed when I was buying these. So it's nothing that you haven't seen a million times before. I'm going to use a desoldering station, but I'm also going to add some nice fresh solder to each of the points as we're going. Just helps to remove them. Just want to give that a bit of a tidy up. Get the last remnants of the old capacitor away. We can then fit the new axial cap, paying attention to the polarity of it. On these things there's a stripe and there's almost like arrows in that stripe. Those arrows are pointing towards the negative side. So that'll go in there like that. And we can solder it up. One down and many more to go. So all the new capacitors are fitted, but before we go any further, as I said, this is my first time inside a ZX Spectrum. First time working on one of these. And while we could solely rely on the schematics, I thought instead what we'd do is ask ZX Spectrum veteran Lee from More Fun Making It to give us a bit of a tour of the board and point out any potential pitfalls that we need to look for.
Hi Glenn, thanks for having me on the channel. You asked me to give you a little look around the ZX Spectrum, and so I thought I'd drag a few of them out, and here we go.
Quick tour around the board. Here we have the Sinclair ROM. This can be two different types, and the wire links here will designate which type you should be using in that socket. The Z80 CPU, we know all about those. The Ferranti ULA, the quite famous beating heart of the Spectrum. Down here we've got the lower RAM. These are 4116 DRAM chips with +5, -5 and +12 volts. If any of those voltages disappear, the RAM is often toast. IC3 and IC4 are what controls the lower RAM. The upper RAM here doesn't fail quite as often. It still goes now and then. That's controlled by these 4 LS74 logic chips. The most common failure points are TR4 and TR5. This is an issue 2, but I will show you an issue. I haven't got a 3B, but I'll show you an issue 4S, which is very similar. It's only a couple of minor differences. TR4 and TR5 are down here. They will go as soon as anything is shorted. That they will almost certainly pop. Once they go, the voltage conversion is all over the place. You can have missing -5 volts down here, and then you'll start losing lower RAM chips. Another fun thing is the center negative polarity of the power supply. People often put in the wrong polarity power supplies, and that will take out the CPU and often other things as well, but the CPU is the first to go on that. The LM1889 chip very rarely fails, so I wouldn't worry a bit too much about that one. ULA, they fail quite often, especially ones ending in 6 and earlier. The 7s are pretty robust. I think they got better at making them as they went along. The ROM and the CPU are usually soldered direct to the board. The ULA is in a socket from the factory. If you want to protect the ULA, you'll have to remove the socket, solder it direct to the board, and then put a heat sink on. It won't fit without taking the socket away. Quick recap then, TR4 and TR5 are the main culprits. Make sure that they're working okay and then put some voltage in. Lower RAM is the thing that always fails first. Once you've got all that working, then you can see what else is broken. I hope you found that useful.
So thank you very much, Lee. That was very informative, and I highly recommend checking out his channel, More Fun Making It. I'll leave a link in the video's description. He's recently done a video series on repairing one of these, a ZX Spectrum, that was in rather sorry looking condition. Excellent video series, highly recommended. Make sure you go and check it out. Now the other thing that he said to me as well, just in conversation, was to check for shorts. So that is the first thing we're going to do. We're going to check those 3 voltage rails. So we've got +5, -5 and +12, and we can start by checking the +5 over here on the voltage regulator. So the middle pin of it that is the ground. The pin on the right hand side here, that's actually the output. You would almost think it was that pin. You know, this one would be the input connected to this, but nope, it's the pin on the right hand side. And there's no short there. Let's just turn the meter way up. Yeah, so that's reading about 4K. That's fine. For the other voltage rails though, the plus 12 and negative 5, we can test those on the RAM chips. So pin 16 on these is ground. That's this one up here. Pin 8 is plus 12. No short there. Again, let's just turn the meter way up. Yeah, so that's reading 2.8K. Pin 1 is the negative 5. And that's, well, started there at about 16K and it just seems to be going to infinity. So again, that's most likely fine. The other thing then that we were advised to test is the two transistors, TR4 and TR5. And just because we have the desoldering station still out, probably best just to remove them from circuit. So TR5, first of all, I've got the meter on its diode test. Negatively goes on to the center pin, and then on the two outer pins we should see between say 700 and 1000 ohms, so about 800 odd, and same about 800 odd. That's fine. Reversing that, we shouldn't have anything. Yep, that's fine. And then just check for short between the outside pins, but I don't think there will be. No, that's fine. That can go back in, and then we can test the other one. And then on TR4 we'll just do the same again. We've got a short, so we have a short between that middle pin and the left hand side one. And it's open the other way. Let's just reverse that just to be sure. Yeah, I think this transistor is bad. We're going to need a new one of those. But with that bad transistor, and with the fact that I think someone reversed the polarity on this DC input, are we potentially looking at a dead CPU and one set of dead memory chips? The new transistors have arrived. Just ordered this box of them from Amazon. Not even going to try and pronounce that, but given where they came from, they're probably not the best quality, although this was the easiest way for me to get them quickly. Not suitable for children under 6 years due to small parts. They obviously start them young, wherever this box of transistors is put together. So the one we are replacing is TR4, a ZTX 650. And if we have a look at the data sheet for that, working left to right here, we have collector, base, emitter. We're going to be replacing it with one of these, an S8050. And if we have a look at the data sheet for it, well, left to right this time, it's emitter, base, collector. So our new transistor needs to go in that way around with the writing looking to the left. Sort of like that, although I'll push it down in and solder it up properly. But since we are changing TR4, I think it would be worthwhile changing TR5 as well. The two of these are on the power rails, and it's probably better to have a matching pair anyway. TR4 is an NPN transistor, TR5 is PNP. And we'll replace that one with one of these. This is an S8550, and that's going to go in there like that. Okay, two new transistors are in. The only thing we have to do now really is test it. So let's hook up our composite signal, our now composite signal, since we've bypassed the RF. And we'll just hook up the original power brick, will we? Moment of truth. Watch out for those fireworks. Let's see what's gonna happen. Absolutely nothing. Let's just bring the meter in here quickly. See if we can find any voltages. Just want to see if there's even voltage getting into our machine. And yeah, there's that 11 point odd volts getting to the 7805. What about coming from it? Have we anything? Not a lot. 0.65 volts coming out of our regulator. I suppose, given my guess that someone reversed the polarity on this DC input, I suppose that could kill the voltage regulator. And luckily I do have some of these in stock, so let's get one of them on there and we can try that again. ZX Spectrum power on take 2, now with new 7805. Watch out for those fireworks. Okay, so we have some signs of life, although they are a bit screwed up, aren't they? Let's just take a quick look at those voltage rails. We can do that on the RAM chip here. So pin 1, that was the -5 volts, and it's sitting at -4.9. I think that's close enough. Pin 8, that was the 12 volt, and it's getting, well, just over 12 volts. And then pin 9, that was the +5, and it's sitting at more or less +5. I've left it running there for a couple of minutes. I just want to have a feel about to see if any of the chips are getting particularly hot. Now, the fact that we have that white grey sort of background, I've been told that that should confirm that our CPU is indeed running. In fact, given that there is motion on the screen, as in, you know, there's colours flickering there, yes, the screen is a mess, but that in itself would suggest to me that the CPU is indeed doing something. Our Z80 is running. Having a feel about the board, there's nothing here that feels particularly warm. Well, the ULA has quite a bit of heat in it, but I think those do run a bit warm anyway. Bit of heat in the CPU, as you would expect. And there's a wee bit of heat in the ROM, which I probably wouldn't have expected. The logic chips there that I can get to anyway, they all are fine, they're all cold. But considering that Lee told us when TR4 goes there, you're going to lose one of the voltage rails, potentially cause damage to one or all of these memory chips, considering the corruption we have on screen, well, the first thing that I would have thought of anyway is a bad RAM chip. So I'm just going to hit pause on this video for now. We've managed to get the board powered up, but obviously there are more faults to contend with. So next time we'll take a closer look at those and see if we can't get it fixed once and for all. Make sure you go and check out Lee's channel, More Fun Making It. He's got a few videos on repairing these ZX Spectrums. So head over there, give him a sub, and make sure to tell him that CRG sent you. As for this video, sorry to cut it in half, but I'm going to have to order more parts. So rather than postpone releasing this part of it, I'd rather just put it out there. And sure, if anyone watching has any suggestions for what to try next to get it fixed, please let me know in the comments. But that's it for now. So if you enjoyed what you've seen, I would appreciate a big thumbs up. Why not hit subscribe so you don't miss the next part. Still plenty more yet to come here on CRG, and I'll see you next time.